Here is a smell that shows up in almost every automation project that was not designed carefully. You open a test file and you see strings like this. User ID 12345. Email john@test.com, password test123. Order ID 99999. Product SKU-A-001. These values are hard-coded. Someone typed them in when writing the test. They work today. In 6 months, that user ID does not exist anymore. The product SKU changed. The test environment was rebuilt and all the IDs shifted. Suddenly half your suite is failing and nobody knows why. Or worse, 2 developers are writing tests at the same time. Both use email john@test.com, both tests pass in isolation. Run them together and they collide. Hard-coded test data is a time bomb. It works until it does not. And when it stops working, the failure is mysterious and hard to trace. The solution is test data management. A deliberate strategy for creating, using, and cleaning up the data your tests need. In this episode, we are covering the main approaches. Factory functions and fixtures for generating data programmatically. Parameterization for driving many test cases from one function. External data files for large datasets. And the patterns that keep your database clean between runs. Good test data management is what separates a suite that degrades over time from one that stays reliable as your system grows. Let us start with the most common pattern, factory functions. A factory is a function that creates a data object with sensible defaults, but lets you overwrite anything you need. Here is a simple example. A function called makeUser. It takes keyword arguments for name, email, and role, with defaults for each. The email default uses a UUID to guarantee uniqueness. The function creates the user in the database, or in memory, and returns the object. In your test, instead of hard-coding a user, you call makeUser. Need a specific role? Call makeUser with role equals admin. Need to test something about the email? Pass in the email you want. Everything else gets a sensible default. This pattern has 3 big advantages. First, your tests describe intent, not data. A test that calls makeUser with role admin is clearly testing admin behavior. A test with a hard-coded user ID tells you nothing. Second, uniqueness is built in. No collisions between tests. Third, when your data model changes, you update the factory once. Every test using that factory automatically gets the update. Pytest Factory Boy is a library that integrates the Factory Boy library with Pytest fixtures. It generates fixtures from your factory definitions automatically. But you do not need any library to use this pattern. A plain Python function that creates data with defaults and UUIDs gets you 80% of the benefit with 0 dependencies. Parameterization is how you run the same test with multiple sets of data, without writing the test multiple times. Pytest's parameterized decorator takes a list of inputs and runs your test once for each. Here is the practical example. You are testing input validation on a form. You want to test empty string, null, string too long, string with special characters, valid input, and borderline valid input. Without parameterization, you write 6 test functions that are almost identical. With parameterization, you write one test function and pass a list of 6 tuples. Each tuple is one test case. Name, input value, expected result. Pytest generates 6 separate test runs, each with its own name and the output. If one fails, you see exactly which input caused it. This is how you implement boundary value analysis in code. Every boundary becomes a parameter. The test logic is written once. You can also parameterize with external data. Load a JSON file. Read a CSV. Query a fixture database. Pass that data into parameterize. Now your test coverage scales with your data file, not with your test code. For API testing, this is especially powerful. One test function handles valid requests, invalid requests, edge cases, missing fields. The test logic stays the same. The data changes. When a new edge case is discovered in production, you add one line to your data file. No new test function needed. Let us look at a full test data setup with code. We have a login feature. We want to test valid credentials, invalid password, non-existent user, empty username, empty password, and SQL injection attempt. The old way, 6 separate test functions, each with hard-coded values. Here is the new way with parameterization and a factory. First, in contest.py, we define a make user fixture that creates a test user. With a unique email and a known password, yields it to the test, then deletes it. Second, we define our test data as a list of tuples. Each tuple has a test ID string, an email modifier, a password, and the expected HTTP status code. For the valid case, we use the real credentials from the fixture. Status 200. For wrong password, same email, wrong password. Status 401. For non-existent user, a fake email that was never created. Status 401. For empty fields, empty strings. Status 400. For SQL injection, a classic injection string in the email field. Status 400. Then we write one test function, decorated with parameterize. The function receives the user fixture, the test inputs, and the expected status. It makes the request and asserts the status code. 6 test cases. 1 test function. 10 lines of logic. And when you add a new edge case, you add 1 tuple to your list. That is test data management in practice. One more area to address, database cleanup. Tests that write to a database leave data behind unless you explicitly clean it up. Left behind data causes 3 problems. Your database grows without bound. Eventually it is slow or full. Tests that search for data find unexpected rows and fail. And test runs become order dependent, because early tests leave data that later tests depend on. There are a few cleanup strategies, each with trade-offs. The delete strategy, your fixture deletes what it created after the test. Simple. Works everywhere. But if a test fails mid-run, the cleanup might not execute. Use yield in your fixture to ensure cleanup runs even on failure. The transaction strategy, wrap each test in a database transaction. After the test, roll back. Nothing is persisted. This is the cleanest approach and the fastest, because rollback is cheaper than delete. It works well with SQL Alchemy and Django ORM. It requires a bit of setup but pays off immediately. The isolated database strategy, each test run gets its own database. Spin it up before the run, drop it after. Works great in containers. Overkill for small suites but essential for teams running many parallel pipelines. For most projects, the transaction strategy is the right default. Yield fixture, open transaction before yield, rollback after. Every test starts with a clean slate. No accumulation. No interference. Combine that with factory functions and parameterization and you have a data strategy that will hold up as your test suite scales. Here is the summary. Hard-coded test data is fragile. It breaks when IDs change, collides in parallel runs, and makes your tests harder to understand. Factory functions give you dynamic data with sensible defaults and guaranteed uniqueness. Parameterization lets you drive many test cases from one function, scaling your coverage without scaling your code. Transaction-based cleanup ensures your database stays clean without brittle delete logic. Combine these 3 patterns and your test data is no longer a source of failures. It becomes a feature of your suite. Readable, maintainable, and built to grow. Up next, CI/CD deep dive for QA engineers. We are going beyond the basics and looking at how to build a full GitHub Actions pipeline that runs your tests on every pull request, generates reports, flags flaky tests, and sends notifications when something breaks. This is what your automation looks like when it is actually integrated into the team's workflow. Not just tests that run, but tests that are part of the delivery process. Subscribe to QA Career Lab and you will not miss it. One more episode after that and we will wrap up this series by building a complete, portfolio-ready automation framework from scratch. See you tomorrow.